Hey everyone, in this AP Chem series video, we're going to take a look at the Arrhenius theory of acids and bases. First, remember from the last video we saw that acids are substances that ionize to produce H plus ions like the hydrogen chloride molecule shown here, and bases are ionic substances or molecules, both of which producing hydroxide ions when added to water, like the sodium hydroxide shown here. In this video, we're going to go just a little bit deeper and take a look at one of the specific theories that is used to explain why various substances exhibit acidic or alkaline behavior. I'm of course talking about the Arrhenius theory of acids and bases. It was developed in the late 1800s by Swedish chemist Svante Arrhenius. You can check out this dude in the bottom right hand corner. And what he said sounds a whole lot like what we covered already in the first video. He was just the guy that sort of officially stated this idea. He described acids as substances that ionize to yield H plus ions in aqueous solution. With this theory, we can often write a chemical equation to show how this process works. Let's do that for HCl, hydrogen chloride. To show how hydrogen chloride produces an acidic aqueous solution, I'm going to start by putting HCl on the reactants side of a chemical equation. The next thing I need to do is identify the hydrogen that will dissociate off from the rest of the molecule and produce that H plus 1 ion. Usually it's pretty obvious to find and listed first in your formula. And lastly, in the products side of the equation, I simply write that hydrogen separated from the rest of the molecule here, H plus Cl. This dissociation will produce ions, so I want to show the charges of these particles, H of course with a +1 and Cl with a -1. I'm also going to include parenthesis AQ after each of these just to show that this is all taking place in water and these ions are dissolved in that water. So this equation is now finished, and it's a great way to show why HCl is considered an acid. I can see that it fits the Arrhenius description of ionizing to yield H plus ions because those H plus ions are shown in the products. Arrhenius also described bases in a similar way. He said that bases are substances that ionize to yield hydroxide ions in aqueous solution. Let's do the same thing and write an equation to show how this works for a substance like magnesium hydroxide, MgOH2. We'll start in a similar way by putting the substance in question on the reactants side of the equation, MgOH2. Next, I'm going to dissociate those hydroxide ions from the rest of the formula here. That's going to give me magnesium separated from the OHs. This dissociation is an ionization process, so these new separated particles will have charges, Mg with a +2 and hydroxide with a -1. With this particular one, we have some balancing to take care of as well. You can see that magnesium hydroxide actually has 2 hydroxides for every magnesium, so I have to represent that in my equation, showing that this will actually produce 2 OH minuses. And since this is taking place in water, of course, my ions are likely to be dissolved in that water, so I'll represent that by putting a Q with each ion. So that's the completed equation, and it's a great way to show how a substance like magnesium hydroxide fits the definition of a base, since in the products I can see that it has dissolved or ionized to yield hydroxide ions. These definitions and equations make up some of the key ideas for this video, so make sure to take some time and write those down. Before we wrap it up, it's worth pointing out that there are some problems with Arrhenius theory. It's pretty good at explaining how and why lots of substances are acids and bases, but it doesn't work for everything. The best example is ammonia NH3. If you tested ammonia with one of those little pH test strips, it would turn dark blue or purple, clearly indicating that ammonia is a base and exhibits alkaline behavior. This is strange though, because if you look at the molecule NH3 or the formula NH3, you'll see that it does not contain hydroxide ions like the bases that we've seen so far. And this doesn't mean that Arrhenius was incorrect, it just means that the Arrhenius theory can't be used to explain how all substances are acids and bases, so eventually we're going to need a more inclusive theory. Now let's officially close this out with a little practice. There are 4 substances listed here. See if you can identify which of them would produce acidic solutions when added to water. And if you find them, write an equation for those according to the Arrhenius theory. To support your answer, go ahead and pause the video and try that yourself first. Now let's take a look at the answer to this. Out of these 4, there are 2 particles that will produce acidic solutions in water, HBr and HSO4-. Calcium hydroxide contains hydroxide ions, so it will clearly function as a base. And you might have spotted that CH3NH2 contains nitrogen and looks a whole lot like ammonia NH3. Substances like this will not function as acids and will instead function as bases. For HBr, I can show that it fits the Arrhenius theory by showing that when added to water, that hydrogen bromide will dissociate, producing H plus and Br minus ions, of course the acidic behavior coming from the production of those H pluses. And a similar thing for HSO4 minus ions, if you put some of those into water, they're going to dissociate as well into H plus and SO4 minus 2. And that wraps it up for this video on the Arrhenius theory of acids and bases. Thanks for watching, and here is a brief summary.